My name is Randy Richmond, manager of RightHand Engineering, and we are standing here at the town of LaConner, Washington's community solar project located at the town's waste treatment center. Here behind me is the public kiosk display for the project used to educate the public and especially local schools. The kiosk display screen and the associated web-posted information are part of a monitoring system which we at RightHand Engineering supplied. This monitoring system monitors the solar insolation or radiation that reaches the 3,600 watts of photovoltaic panels on the roof of this compost shed. It also monitors the PV array output and its conversion to AC grid power. The charge controller and inverter which perform this power conversion are in this cabinet. This happens to be an Outback power system, but the town has plans to expand the system in the near future, and it's likely that there will be some other manufacturers' inverters added to the system. So our monitoring solution has been designed to work independent of the inverters, a universal solution, so to speak. When we at RightHand Engineering speak of a monitoring system, we mean a system that measures, logs, and alarms the power system. Our system uses a hardware interface, as shown here, to which a variety of sensors can be attached, including solar insolation, wind speed and direction, temperature, DC voltage, amperage, and power, as well as AC power. The same interface can also measure a variety of analog sensors, and the town has chosen to include a pair of compost temperature sensors, which aids their staff in knowing when a compost pile has cooked long enough. This too is part of the educational display which the town uses to promote not only green power, but also the principle of recycling waste into valuable fertilizer. Let's take a closer look at the kiosk. This kiosk display touchscreen is driven by a Windows 7 PC which hosts our WinVerter Environmental Monitor software. But typical visitors are unaware of what kind of computer is being used because WinVerter Environmental Monitor takes full control of the screen, preventing visitors from getting around the on-screen buttons of our software. The buttons on the screen allow the visitors to see real-time measurements, a strip chart of the last 24 hours of power generation, a textual comparison between various periods of time, an efficiency display comparing solar insolation versus system power output, and historical graphs of prior days, months, and years. The screen can also be put into an auto-rotate mode which sequentially moves through each type of display. While these things are being displayed to the visitors, in the background the PC is also generating web pages, which are then uploaded to the town's web host and is made available on sites such as solarforourschools.org. Let's take a closer look at the monitoring system hardware. A central component is the sensor interface, to which is connected sensors for solar insolation, AC power, PV panel temperature, and compost pile temperature. The sensor interface feeds a PC, which has a touchscreen monitor, and is connected to the internet for exporting web pages. We at RightHand Engineering specialize in beyond the ordinary renewable energy monitoring. This particular application was special because the town wanted a public kiosk, whereas most renewable energy manufacturers only offer web displays. Our solutions are also ideal anytime there are multiple manufacturers of power equipment being used. This system was in need of our solution because of their plans to use inverters from Outback as well as other manufacturers. But the same would be true of a system which, for example, used PV arrays to power electric vehicle charging stations. We hope you found this brief case study helpful in understanding our unique capabilities here at RightHand Engineering. Thank you.